Derivatives of implicit functions. In this module, you will learn how to find the derivatives of implicit functions. You may already know that we generally express a function in the form y equals f of x, where x is an independent variable and y is a dependent variable. However, we may not always express functions in this form. At times, we express them like this. However, undoubtedly, in either of the cases, y depends on x. While we can solve the first function for y easily, we may find it difficult to solve the second one for y. When a relation between x and y is easy to solve for y, we say that y is an explicit function of x. Otherwise, we say that y is an implicit function of x. Explicit means expressing clearly. So, y is an explicit function of x means that y can be expressed clearly in terms of x. In contrast, implicit means indirect. So, y is an implicit function of x means that y cannot be expressed directly in terms of x. Here, we will look at how to differentiate implicit functions. Suppose we need to find the derivative of y with respect to x if x square plus xy plus y square equals 100. Clearly, the equation represents an implicit function. We begin with differentiating the equation with respect to x. Applying the chain rule and product rule for differentiation, we get 2x plus x times dy by dx plus y plus 2y times dy by dx equals 0. Solving this equation for dy by dx, we get minus 2x plus y upon x plus 2y. Let's look at one more example. We need to find the derivative of y with respect to x if sine square x plus cosine square y equals 1. Again, the equation represents an implicit function. We begin with differentiating the equation with respect to x. Applying the chain rule for differentiation, we get 2 times sine x into cosine x plus 2 cosine y times minus sine y into dy by dx equals 0. Recall that sine 2 theta equals 2 sine theta times cosine theta. Use this identity to change the equation into sine 2x minus sine 2y times dy by dx equals 0. Solving the equation for dy by dx, we get dy by dx equals sine 2x upon sine 2y. Similarly, we can differentiate other implicit functions. In this module, you have learned how to find the derivatives of implicit functions.